Did you know a fully formed hurricane releases the same amount of energy as 10,000 nuclear bombs every day? Yes, you heard it right. This isn't some wild speculation, it's a fact, a testament to the raw, untamed power of Mother Nature. But how does a hurricane, essentially just a large storm, manage to unleash such immense energy? The answer lies in the process of its formation. It all starts over the warm ocean waters near the equator. When the surface temperature reaches at least 26.5 degrees Celsius, a phenomenon known as evaporation begins to occur. The warm, moist air rises, creating a low-pressure area underneath. This low-pressure area is quickly filled by more air, which also becomes warm and moist, and rises. This cycle repeats, creating a system of thunderstorms with high winds and rain. But we're not at the hurricane stage yet. For that, we need a little spin. The Earth's rotation causes these thunderstorms to start rotating, creating a cyclone. The cyclone continues to suck in warm, moist air, which rises and cools, releasing heat. This heat release is what fuels the hurricane, making it stronger and more powerful. And just how much energy are we talking about? Well, a fully formed hurricane can release up to 200 times the world's electrical generating capacity, every single day. But don't let this scare you too much. While hurricanes are indeed powerful, they also play a crucial role in our planet's weather system. They help distribute heat from the tropics to the cooler regions, maintaining the Earth's overall temperature balance. So next time you see a hurricane on the news, remember the immense power they hold. These aren't just simple storms, they're massive heat engines, powered by the sun, driven by the Earth's rotation, and capable of releasing energy on a scale that's hard for us to even comprehend. But remember, this power also serves a purpose, a vital role in the complex and beautiful system that is our planet's weather. Guess what? The fastest hurricane ever recorded traveled at a staggering 190 miles per hour. Yes, you heard it right, hurricanes can really move that fast. Now let's take a moment to understand the speed of hurricanes. They usually range from 74 miles per hour, which is the threshold for a Category 1 hurricane, all the way up to the aforementioned 190 miles per hour. These speeds aren't just impressive on paper, they translate into a force of nature that can cause unthinkable destruction. Imagine the power of that wind, ripping through cities, tearing roofs off of houses, and turning everyday objects into destructive projectiles. The sheer speed of these storms also means they can cover large distances in a short amount of time, leaving a trail of devastation in their wake. That's faster than most high-speed trains. Ever wondered how big a hurricane can get? The largest one on record was Typhoon Tip, which was about half the size of the United States. That's right, hurricanes can grow to be incredibly massive, dwarfing entire countries. Let's put that into perspective. Imagine a storm stretching from New York to Los Angeles, or from London to Moscow. That's the size of some of the largest hurricanes ever recorded. It's like having a swirling mass of wind and rain the size of India or Argentina. These colossal storms are not just freaks of nature, they're powerful, destructive forces that can cause immense damage over vast areas. When a storm of this magnitude makes landfall, it's like a giant bulldozer plowing through everything in its path. So next time you look at a weather map and you see a hurricane, remember the sheer size these storms can reach. Imagine half of America being covered by a single storm. It's not just Earth that experiences hurricanes. Jupiter's Great Red Spot is a hurricane that's been raging for at least 300 years. Yes, you heard it right. Hurricanes are not an Earth-exclusive phenomenon. In fact, they can be much more extreme elsewhere in our solar system. Take Jupiter, for instance. Its Great Red Spot, a massive hurricane larger than Earth itself, has been swirling for centuries. Unlike Earth's hurricanes, which last for a few days or weeks at most, Jupiter's storm shows no signs of slowing down. And it's not just Jupiter. Saturn, Neptune, and even the Sun have their own versions of these swirling tempests. Saturn's hurricane has an eye that is a whopping 20 times larger than the average hurricane eye on Earth. Meanwhile, the Sun's solar hurricanes, or solar tornadoes, can reach speeds up to 500,000 kilometers per hour. So while Earth's hurricanes can be devastating, they are relatively mild compared to what the rest of the solar system has to offer. Imagine a storm that lasts for centuries. The deadliest hurricane in history was the Great Hurricane of 1780, which killed approximately 22,000 people. This storm swept through the Caribbean, leaving a trail of devastation in its wake. But it's not alone in the annals of deadly hurricanes. In the United States, the Galveston hurricane of 1900 holds the grim title of deadliest storm, claiming between 6,000 to 12,000 lives. The storm surge, peaking at a staggering 15 feet, wiped out the Texas city. Fast forward to the 21st century, and we meet Hurricane Mitch of 1998. This Central American monster caused over 11,000 deaths, primarily due to catastrophic flooding and landslides. Let's not forget about Hurricane Maria in 2017, which resulted in nearly 3,000 deaths in Puerto Rico alone. The sheer power of these storms, their capacity for destruction, is humbling. They remind us of the raw, untamed force of nature. These storms are not just destructive, they're deadly. Climate change is making hurricanes more intense and frequent. It's a chilling fact that we must face as we delve deeper into the relationship between our changing climate and these powerful storms. Now let's take a moment to understand why this is happening. You see, hurricanes are fueled by warm ocean water. As temperatures rise due to climate change, the oceans are heating up too. This creates more energy that hurricanes can draw upon, allowing them to grow larger, more powerful, and potentially more destructive. But it's not just about power. The frequency of these storms is also on the rise. Warmer waters increase the chances of hurricane formation, leading to more storms each season. And with more storms, the odds of a particularly devastating one hitting land also increase. Moreover, climate change affects rainfall patterns, leading to heavier downpours during hurricanes. This means that when a hurricane does hit, the risk of catastrophic flooding is much higher than it used to be. And let's not forget about sea level rise. As glaciers and ice sheets melt due to global warming, sea levels are rising. Higher sea levels mean that storm surges, the walls of water that hurricanes push ahead of them, become even more destructive. So, it's a harsh reality we're living in. Our changing climate is making hurricanes more dangerous. But it's also a wake-up call. The decisions we make and the actions we take can help mitigate these changes. By reducing greenhouse gas emissions, investing in renewable energy, and building more resilient communities, we can help break this vicious cycle. And yet, it's not just about what we can do as individuals. It's also about what we can achieve collectively as a society. We need to push for policies that address climate change on a broader scale, because tackling this issue is crucial to reducing the risk of destructive hurricanes. It's a vicious cycle that we need to break, and with knowledge, action, and collective effort, we can and we must. Ever wondered why hurricanes have names? It's to help meteorologists and the public track them. Unleashing their fury with a name, these storms are not just a random occurrence. The World Meteorological Organization, a specialized agency of the United Nations, is responsible for naming these tempests. They utilize a system of short, easily remembered names in written and spoken form. There's an established list of names that rotate every 6 years, with male and female names alternating each storm. It's a fascinating system that gives each storm a distinct identity, fostering greater public awareness and aiding in effective communication. Interestingly, if a hurricane causes significant damage or loss of life, its name is retired out of respect for the victims and to avoid any potential confusion in the future. So it's not just a cool nickname, it's a crucial tracking tool. So, we've learned a lot about hurricanes today, haven't we? We've delved into their terrifying power, their staggering speed, and their immense size. We've even ventured into the realm of extraterrestrial weather, exploring the possibility of hurricanes on other planets. We've recounted tales of the deadliest hurricane in history and considered the ominous implications of climate change on these intense weather phenomena. We've also discovered the intriguing process behind the naming of hurricanes, a tradition that humanizes these monstrous storms in a strangely endearing way. Now, as we wind down, I want to leave you with something to ponder. Picture this. You're at the World Meteorological Organization, and you've been given the task of naming the next hurricane. What name would you choose? And more importantly, why that specific name? Is there a story or a sentiment behind it? Now here's a question for you. If you could name a hurricane, what would you call it and why? Let us know in the comments below.